This is lesson 1 of the Edexcel A-Level Pure Mathematics Year 2 course. Today's lesson is proof by contradiction. A contradiction is when two statements have a disagreement, so they both cannot be true at the same time. Proof by contradiction uses this to prove that the original statement is either true or false. To set up a proof by contradiction, you first assume the negation of the statement. This means the opposite of what the proof is trying to say. So let's do an example. Prove by contradiction that if n squared is even, then n is even. The negation is the assumption that we make is that there is an n squared that is even, but there is an n that is odd. If n is odd, then we can rewrite it in the form n equals 2k plus 1. If we work out n squared is 2k plus 1 squared, which is 4k squared plus 4k plus 1. We can factor out a 2 from this, which is 2 times 2k squared plus 2k plus 1. However, anything times by 2 is an even number, but if you add 1, then it must be odd. So n squared is odd. That contradicts the original assumption that n squared is even. Therefore, if n squared is even, n must be even also. Let's do another example. This time, we're going to prove that root 2 is irrational. All rational numbers can be written in the form a over b, where a and b are integers and that they are co-prime. What this means is that the greatest common factor between a and b is 1. For example, a half is rational and maybe 3 over 4, but not 3 over 6, because the greatest common factor here is 3. So let's set up our assumption. The assumption is that root 2 is rational, is a over b, where a and b are integers and are co-prime. Let's square both sides. We get 2 equals a squared over b squared. Multiply both sides by b squared. We get a squared equals 2b squared. From the first example that I did, we prove that if n squared is even, then n must be even. So because a squared is a multiple of 2, that means a is a multiple of 2. Or we can write a equals 2k. Now let's put this back into there. 2k squared equals 2b squared. So 4k squared equals 2b squared. So b squared equals 2k squared. And because b squared is even, that means b is a multiple of 2. However, this is a contradiction, as if a is a multiple of 2 and b is a multiple of 2, then both of the numbers can't be co-prime. That's a contradiction, so we can say contradiction. Therefore, root 2 is irrational. Simple. I'll do one final example. I'll say, prove that there are an infinite number of prime numbers. So you assume that there are a finite number of prime numbers. This means you could list them all out. Prime number 1, prime number 2, prime number 3, and so on and so forth, until prime number n, the last one. If we let the number n equals all of the prime numbers multiplied together, p1 times p2 times p3 times all the way up to pn. But now, if we add 1, if you divide n by any of these prime numbers, you'll get the remainder of 1, which means it's not divisible by any prime. So, either n is prime, or it has a prime factor. And that means, but it's not in this original list. So n is either prime or has a prime factor. The prime factor isn't in the list of all primes. Contradiction, therefore, there is an infinite number of prime numbers. Proof by contradiction can be used to prove several statements like this, where you usually start with the original statement, assume the negation, the opposite of the statement, and then show mathematically with steps that there is a contradiction, and so the original statement must be true.